Hi, everyone. Welcome to the latest installment of our ongoing editorial webinar series, Coffee Talk. Each hour-long information-packed episode, organized by the hardworking folks at Redmond Magazine, features the observations and insights of independent experts on a wide range of tech industry topics. Many thanks to the underwriting sponsor of this episode, ControlUp, providing a digital employee experience management platform designed to equip IT teams with the tools they need to quickly resolve issues, proactively prevent tickets, and minimize costs. Without their support, this series would not be possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of the Converge 360 Group of 1105 Media, and I'll be your moderator. Today's topic is End User Experience Monitoring 101, and our lead presenter is Joey D'Antoni, Principal Consultant at Denny Cherry and Associates. But before we get started, just a bit of housekeeping. This episode is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way in the next few days. We'll make some time during the talk for questions. Please feel free to type your questions into the Q&A box at any time. Our sponsors provided some extra resources you definitely won't want to miss. They're available now on your console. And as a small thank you to the first 200 attendees who stick with us to the end, we will be sending you a $5 gift certificate to Starbucks. It's a cup of joe to go with the info. Now let's meet our first speaker. With more than 2 decades of experience at Fortune 500 companies, Joey D'Antoni has become a well-known thought leader in cross-platform IT. He's both a VMware vExpert and a Microsoft Data Platform MVP. He has worked extensively on database platforms and cloud technologies, and he has a high level of expertise in performance tuning, infrastructure, and disaster recovery. You guys are in for a great session. Take it away, Joey.
Thanks, John. And hi, everyone. And I'm Joey. And like John mentioned, I'm a consultant at Denny Cherry and Associates Consulting. And I do a lot of work with a wide variety of customers, doing all sorts of various performance tuning tasks on every level. But I wanted to start this presentation out with a kind of a story, because I think it's always interesting that when we can tell stories and share from our shared experiences. So I've been working with DCAC since, I think, 2014. I can't remember exactly. But the last real job I had, as in not being a consultant full-time, was I was a principal architect at Comcast, which is my title, and I was responsible for database systems and big data. So what that meant was I didn't have to be on call, which was really nice, and I could tell the DBAs when they were wrong and what to do, which was my favorite part of the job. No, just kidding. But it meant kind of I was on a cross-functional team where we had kind of the experts of each area of infrastructure on our team. What this meant was when we had big problems, we would get brought in to kind of firefight things in addition to, the planning stuff we did. Well, Comcast.com at the time had some performance problems, and we looked at everything and evaluated hardware. And this was kind of back a long time ago. So 2012, 2013 timeframe. And Comcast is actually a little bit slow to adapt the virtualization. So most of the hardware in question was physical hardware. So stuff running on bare metal infrastructure, nothing in cloud at the time. But we evaluated a lot of things. So we looked at databases, servers, storage, and there were some database performance issues. And one of the things you'll notice in the theme throughout this presentation is that a lot of times as IT professionals, we only think about the back end of systems. We have all these tools and techniques for how we can look and analyze database performance, server performance, storage performance, and we can even use tools like Grafana and Kibana to combine all of those things into a single dashboard. But one of the things we don't always look at is the end user experience, and what is that end user feeling? And what kind of timings are the end user having? So what we did was we did deep dive performance analysis of the infrastructure layers, like any good server admin and DBA would do. However, what no one mentioned until pretty late into the process was the website itself. When you went to Comcast.com, it loaded 25 megabytes. And I know that doesn't sound like a lot, especially in a world where we have like petabytes that we can allocate to a VM in the cloud. But 25 meg is still a big chunk of data to load to a single web page, especially your front page, when you're loading it directly from the web tier. At the time, we had no content delivery network in place. And I'm going to talk more about CDNs in a bit. But what that means is that was landing in that was hitting, if you went to Comcast.com, you were hitting, our DNS and then going through a load balancer and then pulling 25 megabytes of data from our web server in our data center in the Philadelphia area to your browser. I think we might have had geo load balancing. So if you're on the West Coast, you might have been going to Denver. But that location was happening in the website. There was no content delivery network in place. So the way a CDN works is, I'm in New York right now. I'm speaking at a conference. And what would happen is, if I'm in New York, I might not hit a CDN, but we might have a CDN in New York because the population here is large enough that like images and large files that were loaded on the website would be cached. So the second time someone from New York hit that endpoint, the site would load a lot faster. So there was no caching anywhere in this layer. So we had all sorts of things wrong with our site. And what happened is we were chasing, as system admins, we were chasing milliseconds and microseconds when we should have been chasing seconds. And where you lose that a lot of times as an IT professional is when you focus too much on the back-end systems and not enough on what your user is experiencing. And that's what we're going to kind of talk about today. And it's frequently important to look at the back-end system, but it's also important to understand what your users are seeing and how they're experiencing that. So one of the trends, I guess, that I've, pardon the pun, observed in recent years is we used to call things monitoring. And now we tend to call what we used to call monitoring observability. And I don't really know when that changed. It seemed to be around when Kubernetes got popular. But it's conceptually the same thing. I'm sure there's a full definition that would explain the differences to you. But to really understand your application's end-to-end behavior, you need to capture metrics at each layer, from the user down to the storage layer. And this is something I've always heard from like performance tuning experts, and as I was learning to be better at performance tuning, this was something I always wanted to understand, because when I was a young DBA, I was like, I can only see things in the database. How do I know, what this data is doing when it gets to the app tier, and then how is it being served to a user? And that was when apps were really simple. We had a big fat client app and a database. Now apps are far more complex. So we have much more complex application topologies, and we'll kind of talk through some of the topology of a modern application and how those tend to work. But there tend to be a lot more layers. Like, one of the things is a lot of systems now don't even have a single database behind them. They have multiple data stores depending on what the use case for that specific data in that app is. But having that picture of end to end can help you isolate where any performance bottlenecks are. And beyond that, you need a way to evaluate this data holistically. So you need to be able to say, okay, it's taking the end user, 23 milliseconds to get to the endpoint. For example, I was watching a bike race last week in Australia, and the updates that were getting posted to Twitter were way ahead of my video on the screen, because I was using a VPN to Australia. And from the East Coast to Australia, in terms of latency, is roughly about 330 milliseconds. So not a great latency scenario, but I could tell you exactly where my bottleneck was. I had a 330 millisecond latency, and text was faster. But being able to evaluate that data holistically is really important. It's network, it's multiple layers, it's interchanges between systems. These are all challenges that I find working with different customers we run into a lot. And many architects and administrators struggle with understanding this concept of looking at the whole picture and seeing where things are. A lot of times, I know I'm guilty of this. I'm always quick to go, hey, what's going on in the database? And it is always going to be the first thing I'm going to look at, because I do know that it is like the center of a lot of performance problems. But you have to look at the whole picture, because especially if you have some users that are having good experiences and other users that are having bad experiences, is it down to a desktop problem or is it down to a network issue? And there's a lot of complexity there, and we'll talk through that in the next couple of slides. Monitoring end user experience. So this ties back into that. IT wants to default to monitoring back-end performance. I know this because it's what we know. I actually dreamt about this presentation last night, which I don't normally do, but I did. I dreamt up this crazy Azure Remote Desktop demo that I was going to do, which I don't know how I was going to do that because I only have 30 minutes. But anyway, if we look inside of Windows and we look at performance monitoring, and this is just Windows, Linux has its own ecosystem and the same large number of performance monitoring tools. We have thousands upon thousands of counters that we can enable Windows to light up. In fact, one of the ways if we want to generate a whole bunch of data in a hurry for demo purposes is to turn on like as many counters as we can performance monitor in Windows. It's the nature of IT that we're always thinking about the server side, because the servers are kind of our babies. Those are the systems we know. Those are the ecosystems we know really well. And to be absolutely honest with you, those are the easiest things to monitor. I can go in tomorrow or right now, light up 45 perfmon counters and tell you with 95% confidence what's going on in your SQL server. I can do something similar with Oracle on Linux. Like, those are things that are pretty easy for IT to do. Most observability tools are also built around server-side monitoring. So if you're not building your own tools or using custom perfmon scripts, you're buying some tool from a third-party vendor. A lot of those tools are built around server-side monitoring. They want to be able to say what's going on in the application tier, what's going on in the database tier. And there are some tools, like if you've used something like Azure Application Insights or New Relic, that do have some monitoring of like the time from the user going round tripping to the web tier. Those tools are really good from a developer perspective, but they aren't necessarily built around user experience. And that's something you really want to have some better understanding about. What kind of lag time are your users having? What's the round trip? How quickly is the data getting returned, not just from the data stored to the app, but to your user and their device? And let's talk about why that's complicated. And this is really kind of simple. I tried to get this all on one slide, and I pretended like we were in the cloud, and I made this kind of a simple app. In reality, there are a lot more layers than this, and there's a lot more complexity. But when we talk about modern applications, we have a user device. That user device is typically a mobile phone or tablet or a laptop or a PC or whatever. But when we're talking about that, we're talking about a wide array of devices. So right now I'm presenting to you from an Apple MacBook Air with Apple Silicon, and I have my iPhone 15. So I'm kind of on some of the latest stuff. So chances are, if I'm experiencing a performance issue on my device, it's not going to be related to the capacity of my device. But when you're supporting a modern application, you have to support all sorts of devices. And you may have users who have slower devices, older versions of operating systems, different operating systems. And those are all something you have to have some concerns with. Those users are all coming through an ISP. If they're mobile, that could be a cell phone company, and you don't have a lot of ways to get insight into the cell phone. Like if you're large enough, you can get metrics from your cell providers, but you don't always have that. Or ISPs, and some ISPs offer you better data than others. I have a coworker right now who's struggling. He recently upgraded his ISP plan to a gig, and he started having dropouts on his router when he did that. And he's got he does have professional grade routing equipment. So these are things that if you're an application owner, we can't see any of this yet. We can only see like response times, and we don't have understanding around that because we don't have anything on the user device. Here I talk about the edge CDN, and this is the way a lot of modern kind of apps will be developed, where we're having a content delivery network. The big ones are Akamai, Azure, and Amazon both have them as part of their cloud services. And this is going to land kind of large files of yours closer to your users, wherever they are. And this is kind of a really basic way to get data in your applications closer to your users. The other thing that a CDN does is reduces the load on your application and data store tiers. Because, for example, if you're loading images onto your site, let's just say you're storing them in S3 or Blob Storage, instead of round tripping to Blob Storage every time you go to retrieve an image that's on your homepage, it's going to be loaded to your content delivery network. And that content delivery network is going to be closer to your users than your app, unless you have an app that's completely globally distributed, in which case you have entirely too much budget. But even when you have an app that's globally distributed, it's going to help by offloading some of that. Then we're typically going to have some kind of network connection from that CDN back into our backend. I am making the assumption that you're serving from the cloud, but this cloud could also represent your data center. You're going to have an application tier of servers, and that's kind of what that rack represents. You're going to have some kind of data store or data stores, and typically this could be object storage. This could be a database. In all likelihood, if you're building a modern application, it's a combination of both, and maybe some other things like key value stores. So all of these layers have metrics, and typically as an IT team, we're going to be looking at the stuff that's in that back end and maybe a little bit on the CDN to see what our utilization looks like. But that leaves out that whole user experience aspect. We don't know what those user devices are experiencing. We may have some rough ideas if we're big enough that we may have enough data that we can get our ISP data from user ISPs. But we don't have any guarantee of that. And the other thing that's always nice to know is if we have users who have bad internet connections, how does the app perform and what is their experience? Because let's face it, we're going to have users that are living off cell phones or in various parts of the world, or that maybe don't have a good internet connection, or maybe they're at a conference or something and you want to see those sorts of things. So being able to monitor this kind of application architecture from end to end isn't something that's done easily, and frankly, it's not something, in my experience working with IT teams all over the world, it's not something that a lot of IT teams do. They're mainly going to be focused on those, definitely the back end and maybe even the CDN. Networks are kind of everything. We were just talking about this over lunch with my team about various options for networking between cloud regions. I'm attending this Microsoft AI conference today when I'm not doing this presentation. And one of the things that came up this morning, and you'll read about this in my column on Redmond Mag, I think tomorrow probably, is that Microsoft has laid 29,000 miles of InfiniBand connections, which is InfiniBand is high speed, low latency, high throughput networking for OpenAI and in their data centers to try to improve their AI offerings to improve performance. As we build these large scale systems, and clouds are all just large scale distributed systems, networks are everything, whether it's moving data between systems in the same cloud region, or moving data out of that region into user devices or into app tiers. It's a big world, and there's never enough bandwidth like we need. It also costs us money, so paying attention to that can be important. Monitoring those edge networks like CDNs or other edge connections are really critical to understanding your app's performance. You want to ensure that content delivery network's doing what you think it is. The other reason why that's so important, and this is kind of a cloud architecture thing more than just a performance thing, is in most cases, you're going to be paying for cloud egress. So data that leaves your cloud provider is going to be metered, and you're going to be paying on a per gigabyte or per terabyte basis, depending on who your provider is. And so you want that CDN to be successful. So you're returning orders of magnitude less data. So designing around those things and monitoring can help that. Another thing that's really important is understanding that user device and connection behavior. We have a lot more bring your own device now, especially around mobile phones. I think bringing your own laptop has faded a little bit, but it's still there because we have some users who will use remote desktop, and I know remote desktop services is something we've gotten a lot of kind of work on recently in the last several months because of some mergers and acquisitions that have happened in the industry, customers are more interested in going to a cloud-based RDP solution, or a remote desktop solution rather. But it's impossible for you to test every device and ISP combo. I was using this one particular piece of screen sharing software that I can't name for disclosure reasons. No, it's not the fault of the software, and I don't even remember the name, to be honest with you, but it required me to have a physical Windows machine to use it. And at the time, I didn't have a physical Windows machine. And it was temporary, so I figured I'd just buy the cheapest one I could off Amazon, and I bought like this $200 HP laptop that probably would have been a terrible machine in 1985, much less now. And my experience was terrible, and it wasn't the fault of the application. There wasn't anything that they could have done. But you're not going to be able to test that. You're not going to be able to test every ISP. So understanding what your user devices are experiencing and having some way to monitor that is important, because if you notice a correlation of users who are seemingly having really bad metrics around your application, you want to be able to know why. And it's not 2020. I know not everyone is working remotely, but a lot of folks are working remotely still. My wife works for a pretty conservative financial services firm, and she still works from home 2 days a week. But and we see that with lots of employees in lots of industries. Lots of users still work remotely part-time at least. And having important networks and having users who may have dodgy internet connections are definitely something IT has to deal with more than it did in the past. So having tools to be able to better understand what that looks like is pretty important. So why do we focus on the back end so much? And I think this is something that's kind of a universal IT bias. We all like to nerd out and go into the weeds and pull up things like debuggers and profilers and look at real-time stuff that's going on in our systems. And frankly, it's easy because the same people who write the applications that we use are the same people who like to nerd out about such things. And so they make it pretty easy for us to monitor. Like I said, it's really easy to go light up 50 or 60 different perfmon counters and let's light up with Windows. You can configure a multitude of meters to fully understand what's going on in each layer. My favorite part about this, and something I always like to bring up when I'm kind of doing holistic performance tuning, is it's also really important when you're doing this, and even if you're focused exclusively on the back end, to understand the granularity of each system. I remember working with a storage problem where the SAN was only aggregating data once every 15 minutes, and we had data coming in from Windows and SQL Server and Oracle every 15 seconds. So the SAN data was basically useless to us, but those things are all challenging. And I say networking is hard, and what do I mean by networking is hard? There are just a lot of moving pieces. More importantly, we don't own all the pieces. So once the bytes start to arrive in our data center or in our cloud, then we can monitor those bytes, or packets, I guess is the right term to use, as they travel through our network. But from the outside in, we don't have that. We have very little visibility into what that means and what's going on in that world. So I think those are a couple of the challenges we face and why you see so much focus just from IT's perspective on the back end of systems rather than directly what the users are experiencing. So there are some challenges for end user monitoring that we see. And we've talked through some of these, but I just wanted to highlight them before Jeff kind of talks about Control Up and some of the things they can do. We have a wide variety of supported devices. We have different operating systems, different device formats, different device types, different sorts of connections. So we have, and it's kind of crazy how the technology world has evolved. You know, for a while there in the 80s and 90s, we pretty much had a standard set of PCs and we kind of knew how everything worked. And then mobile phones really happened. And I remember getting some of my first data phones, and that was a real adventure. But the other thing that I think kind of happened, and I can't really put a pinpoint on when this happened, is devices kind of got good enough, probably around the time that most computers started shipping with like 8 gig of RAM, that they lasted for a really long time, and solid state drives. You don't have that whole like every 4 years you need to get a new computer. So you end up in a lot of ways with like devices that have older operating systems, and you may be like, why are people still running Windows 7? And it's like, A, they don't know how unsecure it is, and then B, it still works really good on their device, and they don't know any better. So why would they want to change that? So you end up with all these different formats, and it's less of a concern in the corporate environment, but you still have customers, right? And you don't know what your customers are gonna be, what kind of devices they're going to be using. Understanding your user internet performance is a big challenge, just because you can't monitor it. And there are some ways you can design around this, and a lot of the ways we design systems using content delivery networks, using caching at various layers, is all kind of designed to try to minimize the impact of slow internet performance. But websites keep growing because we have bigger and bigger connections, and developers want to give richer experiences. So that's a challenge, and understanding that. And all of these factors will impact your metrics at multiple layers. And you can't always correlate these to necessarily find a bottleneck. And that's something that when you find a bottleneck in performance tuning, it's kind of like the Holy Grail. You're like, okay, we found the problem. Now we can tune around it, or we can figure out what the next bottleneck's going to be, and we can figure out if we need to make any architectural changes around that. But getting to that point, especially when it's happening external to your organization, is something that's challenging even for the best performance teams. And a good example of this is virtual desktops. Some of these live in the cloud, some of these live on-prem. We have users that may be coming in remotely. I know I've worked with customers where I had to come in through a virtual desktop, and in a lot of cases, that's not a great experience. But it depends. Like some of the newer solutions are better. Because of partner reasons, I had to get certified in Azure Virtual Desktop last year, so I learned a lot about it. But it's important to kind of understand what that user experience is like, and what that incorporates, in knowing how you should be able to monitor that. So there's no like kind of holy grail there. I'm sure Jeff's going to tell you how great Control Up is at it, and it is. But you need some kind of tool like that gives you that comprehensive thing, because there's not like, outside of having something like that, there's not necessarily a single metric you can look at when you're having those users coming in on a ISP you don't control, from maybe a device you don't manage. You want to kind of understand what their experience is like, and that's really important to help give them a great experience. And with that, I'm going to take some Q&A before I hand off to Jeff. Do we have any questions, Sean?
We sure do. Remember, everybody, you can type your questions into the Q&A box at any time. We'll do our best to get to all of them. Let's start with this one from Shauna, who's wondering, Joey, how can you identify the impact of an ISP versus a home network for user experience?
This is really challenging, and this is the question. That came up with my coworker the other day. He was like, "Is this my ISP or is it my home network?" And typically, as an application vendor, you don't have, even if you're embedding some callback, some telemetry in your application, it's going to be really challenging to isolate whether that callback is slow because the ISP connection was slow, or if they're on a Linksys router from 2003. So being able to identify that is quite challenging. Hopefully you can kind of isolate it, and where you tend to do this.
And we'll address that in the next half hour. I'm sorry, this is Jeff. We'll address that in the next half hour.
Yeah. I mean, where it's hard to do that, good point, Jeff. And where it's hard to do that is to do that well, you need to be able to correlate all your user activity, and then see if you can see whether it's one user who's standing out, or whether it's all the users. And I'll bag on Comcast since I worked there, used to work there. If it's all the users that have Comcast as their ISP that are having issues, then you can kind of pin it on an ISP. But there's data correlation, and that's where tools can be really helpful, like Control Up.
Okay, by the way, that extra voice you heard there was Jeff Johnson. He's going to be our second speaker. More about him later. Meanwhile, we've got a question here from Lynn, who is a regular attendee at our webcasts. And Lynn is wondering, what are the key metrics and indicators that organizations should monitor to assess the end user experience effectively?
That's a really good question, Lynn, and I'm sure Jeff's going to tell you some excellent stuff about what Control Up can do. What I'm going to tell you is in your applications, what you need to do is be building, like, as part of your application stack, a telemetry pipeline. If you're trying to do this yourself, so that you can collect that data, so you can understand what the user experience is like, and you're collecting those metrics. Because there's not like a single tool. There are some telemetry tools that are built into application frameworks and libraries that will allow you to do that. But there's no necessarily like single metric you can capture. Because remember, most things you're running have to be running in the context of a program or website that you're shipping out to other people. So you have to be collecting data that way.
Okay, we've got one here from Lisa, who's wondering, and you use this term many times in your presentation. When you say network is everything, does it mean that when there are poor network experiences, nothing will go on?
I don't want to say nothing will go on. What I mean by that is and cloud has really accelerated this, but we're building applications that are more distributed and systems that are more distributed than we ever have. Systems used to be a lot more monolithic, like we'd have one or two servers or maybe, a cluster of 4, but now we can have like containers and various things. And when we run out of network bandwidth, it can suddenly become a big bottleneck. And when we talk about user experience, we have a whole nother network that we're not really in charge of. So it's even harder because we have that connection between the end user and our application. So we can do everything we can on our side to like use the CDN and use edge caching to try to improve the user experience. But if they're like coming in over dial-up, that doesn't really help us. So it just means that there's more complexity in the stack.
Okay, here's one from Keith, who's wondering, does the location of users matter to their experience?
Absolutely. I mentioned that Australia example, but I've had the good fortune to travel all around the world. And one of the ways I've done that is by being a consultant and supporting my customers at home when I'm traveling. So I have been on. I remember I upgraded a customer to SQL Server 2016 from like a train between the Netherlands and France. And their server was in a data center in Washington State. So it matters depending on the nature of the application and how things are constructed. It can be really poorly impactful, like you can have a really bad experience. If the application's designed pretty well, I'll give you a really basic example because I manage it with Denny. The DCAC website, we have a web tier in the US and one in, I think, West Europe and Azure. And we have a CDN and stuff. So we can see load times from all over the world. And we pay attention to that because people care. And we're geeks around performance tuning. So we can see all those things. And if you design things well, it can work pretty well, and that distance can be less of an impact. But it's also going to depend on the nature of what you're doing. Because if you're trying to build something that's really transactional in nature, and you have to have a lot of what we call synchronous communication, where a call can't complete until it hears back, and you have an extra 100 or 200 milliseconds of latency, that's going to be a painful experience.
Okay, looks like we've got time for one more question for Joey. This one, Joey, how can we help an application with users all around the world?
So just to kind of reiterate what we were just mentioning, CDNs are really helpful. If you have budget, you can put Azure has 54 regions. Amazon has like 40-something regions. You can put your edge resources closer to your users. And if you have critical systems or critical transactions, that absolutely makes all the sense in the world to do that.